Or okay. So start off with some psi AB. Alice is keeping half of it, right? She hasn't done anything yet, but she keeps half of the state, and then she also keeps the state she wants to teleport, and then she performs some measurement on her half of the state and the unknown state, the psi C. Okay? So when we perform this measurement, Alice is going to get a result. She's going to get her answer being one of these four Bell states, right? We can perform, it's sort of non-trivial, so I'm glossing over a bit, but one can perform measurements in the Bell basis, just like we perform measurements in the spin basis. So your answer then isn't, I got spin up or I got spin down, it's which state, which Bell state do I get? So she performs this measurement, and then she knows which Bell state she has, right? And then all she has to do is she takes that, oh wait, maybe I have to explain a bit more. Okay. Hold up. Okay. So she performs a measurement, she gets an answer for the Bell state in the Bell basis. So let's say, for example, she gets phi AC minus. Okay. Now when she performs that measurement, she knows that this is not the state anymore. This is not the state anymore. This is not the state anymore. Okay? So she knows what Bob's going to get is going to be this state here. Okay? So this breaks now that entanglement of that original state, right? She knows she got that answer, but now that one half of the state is gone. But she knows Bob has that state there. So now what she has to do is use this channel of classical communication to deliver this information to Bob. Okay? And depending on what answer Bob gets from Alice, which state she got, Bob can now perform some local operation on this state to recover the original state, even though he doesn't know what it is. So let me see what that original state was. Okay. So that original state was unknown, alpha psi C up plus beta psi C down. Okay. So even though Alice doesn't know what alpha and beta were, and Bob won't know what they are, she knows that the beta that Bob has is off by a minus sign from the original one. So she communicates this information to Bob, and then Bob performs some local operation on that spin that makes it pick up a minus phase, right? And because phase is related to propagation of waves, perhaps he just needs to shine that photon through a particular kind of wave plate, or subject that spin to the correct to a magnetic field for the correct amount of time, so it precesses and flips. So he can perform some local operation that turns that to a minus to a plus, and now he has a copy of that original quantum state, even though he didn't already know it. So even though after this measurement, nothing traveled physically between these two people, just this one bit, well, 2 bits, because there's 4 things, these 2 bits of classical communication, that state reappears over on this side. It is teleported. Okay. So that's quantum teleportation. So why is this useful? It oftentimes is the case in quantum communication that you want to be able to teleport a quantum state from place to place as a shared resource. It also is useful in quantum computation. Certain quantum gates effectively teleport quantum information between what would eventually be different places on the quantum chip, whatever that ends up looking like, right? So this is a key key process in quantum communication and quantum computation. Okay? Talking about specifically why it's useful, other than that it's just cool, is it take a little bit more work, and maybe you'll get to that a little bit when you do your regular quantum class. Okay, so that's really all I wanted to go through. Last thing, if you have any questions about this or anything else, please start thinking of them. And then when we do our final class, which hopefully we'll do that face-to-face over Zoom, you can ask me whatever questions you like. Okay. I'm not going to give you any homework on this, but it may be an extra credits question on your final. Right? So it may pay off to be a little familiar with the past couple lectures, even though you won't get any homework and they're not part of the regular course curriculum. Okay, so I hope this was a little bit interesting and maybe gave you a better idea of weird articles you see in like Scientific American about teleportation and quantum information and quantum computing and stuff like that. Okay, I'm going to start uploading this lecture. I will talk to you soon.